Hi everyone, welcome back to Physics Corner. I am here again with a few questions from the next set of questions from the set exam of February 2020. First of all, I would like to thank all of you for your valuable feedback and support. Keep supporting me and let's start today's class. Okay. 11th question. The wavelength of the photon emitted when a hydrogen atom goes from the n is equal to 10 state to the ground state. Just write down the expression, Rydberg formula. It's used for calculating the wavelength of the photon emitted when a hydrogen atom goes from one state to another. Okay, 1 by lambda is equal to r into 1 by nf square minus 1 by ni square. Here r is the Rydberg constant, nf is the final state of hydrogen atom, and Ni is the initial state of hydrogen atom. Here Nf is equal to 1 since the atom goes from n is equal to 10, that state to the ground state, right? So Nf is equal to 1 and Ni is equal to 10, and we have the value of R is equal to 1.097 into 10 raised to 7 meter inverse. So just substitute these values into this expression. We will get 1 by lambda is equal to 1.08 into 10 raised to 7 meter inverse, and we have to take its reciprocal, right? So lambda is equal to 1 by 1.08 into 10 raised to 7, which means it's equal to 920 angstrom. 1 angstrom means 10 raised to minus 10 meter, right? So option B is the answer. The next question. How many revolutions does an electron in the n is equal to 2 state of a hydrogen atom make before dropping to the n is equal to 1 state? It's given that the average lifetime of an excited state is about 10 raised to minus 8 seconds. Okay, let's do it. See, you have to remember the value of Bohr radius. Okay, it's 0.53 angstrom. It should be learned by heart. Okay, and velocity of an electron in the nth orbit of hydrogen atom. That can be expressed as Vn is equal to V1 by n, and the value of V1 is also calculated as 2.18 into 10 raised to 6 meter per second. So V1 divided by n gives us the value of Vn, and the radius of nth orbit of hydrogen atom can be expressed as Rn is equal to n square into R1, where R1 is the Bohr radius. Okay, and here it's given that electron is in the state n is equal to 2, right? So here we can find out Rn as R2 as 2 square into R1, which is equal to 4 into 0.53 angstrom, which is equal to 2.12 angstrom. And what we have to calculate is the value of the number of revolutions made by the hydrogen atom in 10 raised to minus 8 seconds, right? So generally number of revolutions made in 1 second can be estimated as Vn by 2 pi Rn, right? Because electrons travel in circular orbits, right? So we can write this equation. This equation actually comes from the equation time is equal to a distance traveled by the particle divided by velocity of that particle. And here what we have to calculate is number of revolutions, which is 1 by t, right? So number of revolutions made in 1 second can be calculated using this expression, and we have to calculate the number of revolutions made by hydrogen atom in 10 raised to minus 8 seconds. So it is equal to 2.18 into 10 raised to 6 into 10 raised to minus 8 divided by 4 into 3.14 into 2.12 into 10 raised to minus 10. That's equal to 8.2 into 10 raised to 6 revolutions, which is given in option D, right? I hope this explanation is clear for you. Okay, we can see the next question. The lowest energy of a neutron confined to a box 10 raised to minus 14 meter across is approximately 2 MeV, 4 MeV, 6 MeV and 8 MeV. You can use either of these equations for calculating the energy eigenvalues for a particle confined to a one-dimensional box is equal to n square pi square h cut square by 2ma square or n square h square by 8ma square. Since we know that h cut is equal to h by 2 pi, reduced Planck constant. H cut is known as reduced Planck's constant, right? Okay, here it's given that the dimension or the length of the box is a is equal to 10 raised to minus 14 meter, and for lowest energy n is equal to 1, we know that, and mass of neutron is 1.67 into 10 raised to minus 27 kilogram, and substituting all these values into this equation, we will get E is equal to 2 mega electron volt. Option A. Now 14th question. The permitted energy values of a particle confined to a box of width L is given by, we have already mentioned the expression in the previous question, right? So we know that it's option C, right? And if you get confused in the examination hall, you don't worry about that. I have a simple tip for you, that you can just use dimensional analysis for checking the correctness of these equations, right? So you will be more confident if you have the sound base in dimensional analysis, and you have to be an expert in that area. Okay, as a physics student you have to be like that. Okay, so the next question, the magnetic moment mu j of an atom in which LS coupling holds has the magnitude mu b is equal to like it's Bohr magneton, and Gj stands for Landé G factor. So what is mu j here? It's given in option B, the correct equation, that is mu j is equal to square root of j into j plus 1 into Gj into mu b. It's a quite simple question, like it's a direct one, right? So you can just refer what is LS coupling. Okay, so option B. Shall we move on to the next question? Identify the nuclei that result from the positive beta decay of potassium 3819. Options are there, like calcium 39, argon 39, calcium 38 and argon 38. Okay, so what is meant by positive beta decay? Generally it occurs for proton rich nuclei, and it is considered as the decay of a proton into a neutron, and this neutron will be will remain in this paranucleus itself, and this paranucleus will emit a positron and a neutron also. So here what we have to understand is that the atomic number of the parent nucleus will be reduced by 1, and the mass number does not have any change, because the proton is converted into a neutron, right? So there will be no change in mass number. So here the atomic number must be 18 and the mass number must be the same, like 38. Okay, so option D is the answer. Clear? All right. Next question. Which of the following molecules would show microwave rotational spectrum Br2, I mean bromine molecule, hydrogen bromide, carbon disulfide? So the concept here is that to be microactive, the molecule must have a permanent net dipole moment. Okay, and only the hydrogen bromide molecule has the net dipole moment here. So option C is the answer. The next question, if A and B are Hermitian operators, okay, let me tell you that it's already solved in my previous videos. You can just go back to those videos, especially for mathematical physics problems. Okay, you can see the solution there. And 19th question, it's also solved in quantum mechanics based videos, like it's given that the ground state of hydrogen atom, ground state wave function, it's given, and we have to find the expectation value of the radius vector of the electron in that state. I'm not going to solve it again, you can check in my previous videos. Okay, next one, evaluate the integral z minus 3 by z square plus 2z plus 5 into dz when C is the circle with modulus z equal to 1, which means the radius of the circle is 1 unit. And it's an interesting problem, my favorite area, so we can solve. See, all we have to do is find out the singularities of this function. Okay, especially singularities or poles can be calculated from equating the denominator is equal to 0 of this function equal to 0. Okay, so z square plus 2z plus 5 is equal to 0, and when solving this quadratic equation we will get the values for z as z equal to minus 1 plus 2i and minus 1 minus 2i, and you can just draw this and mark those singularities there in this picture. See, x-axis stands for the real part and y-axis stands for the imaginary part, and you can see that both of these poles or singularities are outside the region over which we have to evaluate the integral, right? So by using Cauchy's integral formula or by using Cauchy's integral theorem, we can say that the value of this integral is 0. because inside the given area, that's inside the circle with radius 1, the function is analytic there. Yeah, that's why the value of this integral becomes 0 over there. Okay, so option C. That's all for today, and I will be back with other set of questions soon. Keep watching and supporting me. Thank you.